Welcome or welcome back at C Square. Um, in this clip, I'm going to talk about this very interesting property that I found it today. You notice we have here a quadratic function. I put a standard form, ax squared plus bx plus c. I'm looking on this interval between two value x1 and x2, and I want to prove that this quotient, which is nothing else than average rate of change, is equals to this average of the derivative at these 2 points. So let's take a look how we're gonna do it, and I'm gonna try to figure out every single expression. I'm gonna start with this average rate of change, and basically I'm gonna use the quadratic we have, and I'm gonna have a x sub 2 square plus b x sub 2 square plus c, this is f of x sub 2, minus a x1 square minus b x1 square minus c over x2 minus x1. And if you notice, these two cancel out, so we have left, and I'm going to rearrange the terms here, a x2 square minus a x1 square plus b x2 minus b x1 over x2 minus x1. And my next step will be to factor out dA, and then we have x sub 2 square minus x sub 1 square. The same with the b, I'm going to factor out, and the denominator stay the same. Now you notice the numerator, I have a very interesting expression, a difference of square, x2 minus x1, x2 plus x1, plus b and x2 minus x1 over x2 minus x1. And now you notice we have a common factor, this x2 minus x1, this x2 minus x1. So I'm going to factor out, and I'm going to have x2 minus x1. I'm going to open a parenthesis. I should have a bracket, in fact, a times x2 plus x1 plus b over x2 minus x1. And of course now I can simplify these two terms, and the simplest and the final form of this average rate of change for this quadratic is a times x2 plus x1, close the parenthesis, plus b. So now we're going to move to the second expression, and let's see what that is. So first of all, let's see what f prime is. F prime of x, since this is a quadratic, is going to be 2ax plus b. So I'm going to find f prime of x1, which is going to be 2ax1 plus b, and similar f prime of x2, which is going to be 2ax sub 2 plus b. And now we're going to try to get this expression. Let's see what we get. F prime of x sub 2 plus f prime of x sub 1 over 2 becomes 2ax2 plus b plus 2ax1 plus b over 2. You notice we have these two b's, so we can add them. So we have 2ax2 plus 2ax1 plus b over 2 plus 2b in fact. We're going to factor out the 2 and we have ax2 plus ax1 plus b over 2. These two can cancel out and we have the simplest form, which is ax2 plus ax1 plus b. And if you notice, these two expressions are the same. I can factor out the a here and get a times x2 plus x1 plus b, and now you notice they are the exact the same. Okay, so yeah, this is a property that is interesting. It works for quadratics. I have tried to do also a GeoGebra app. You have two screenshots and you can see here one that is very nice and clear. You can notice the slope of the secant line, the average rate of change is -1, and this average of the derivative is also -1. Okay, you can change your quadratic and play with this app. Hopefully it's gonna work. I didn't test it too much. I have another screenshot, and this one you notice it's not very visible, but if you change the A's and B and C, you can get different quadratics, and also by clicking new values you get different points on the quadratics. If you enjoyed this video clip, don't forget to click the like button and come back on C Square for more fun.